In this video, I'm going to demonstrate several examples of taking a root. First of all, when we have a square root symbol with nothing in the crevice of the square root symbol, it's assumed that that number is a 2. So this stands for taking the square root of x to the 5th. In order to take a square root, I'm going to first break the x to the 5th up using a tree method. In the tree, what we do is show the factors of the thing that we're taking the square root of. In this case, we could draw 5 x's, all being multiplied together to make x to the 5th. And when we're taking a square root, what we're looking for in the tree would be pairs of factors. So there's 2 x's that are paired. Here's another 2 x's that are paired. And then this x here is unpaired. It's important to identify pairs here because we're going to break the radical up into 2 radicals at this point, where anything that's paired goes into the left radical and anything that's unpaired goes into the right radical. So these x's will go on the left. The other pairs of x's will also go on the left. And the remaining x that didn't have a partner will have to go on the right. We can now simplify what's in the perfect square part. 4 x's being multiplied together makes x to the 4th. And the square root of x will have to stay as it is because that can't be simplified. Now the square root of x to the 4th is just going to be one of these pairs of factors. It's going to become an x squared. And the square root of x will have to stay as it is. So this is going to be the simplified answer to the problem. But now we're going to look at the same kind of problem using a cube root instead of a square root. Let's say that we're going to take the cube root of x to the 5th. The 3 being in the crevice of the root means that we're taking a cube root instead of a square root. The same procedure can be used as the last example. We would break up the x to the 5th into 5 factors. But this time what we need is triples instead of pairs. Here we see 3 x factors, which form a triple. And then we also see 2 x factors, which don't quite form a triple. I'm going to use the same approach of breaking the radical up. And this time, I'm going to put the 3 x's on the left, which makes x to the 3rd. And I'm going to leave the 2 x's to be put into the radical on the right. This time what we're finding is the perfect cube part of the expression. And then we're finding some other factors which are not quite perfect cubes. So x cubed is the largest cube in x to the 5th. We should now take the cube root of x to the 3rd. So what that's going to be is it's going to be just x. However, the cube root of x squared is going to have to stay because that's as simple as it can be. And this would be our final answer to that question. In one more example, we have a 4 in the crevice of the root. And this indicates that we're going to be taking what's called a 4th root. Similar to before, I'm going to create a tree in order to analyze x to the 9th. We can show that x to the 9th is a product of 9 x's. And this time, since we're doing a 4th root, we're looking for 4 identical factors to identify. Here we see 4 x's, and then we see another set of 4 x's. There's one remaining x who doesn't form a group of 4. So now when we go to group our results, we want to put anything that's a perfect fourth power on the left, and anything that isn't part of a group of 4, that should stay on the right. So all in all, we're going to have x to the 8th here on the left, and just x on the right. We would now find the 4th root of x to the 8th. This can be done on calculator, and it can also be reasoned out if we do a drawing where we show that these x's can combine as follows, where it's x squared times itself times itself times itself. So x squared times itself times itself times itself. This shows that the 4th root of x to the 8th is actually x squared. And we're going to have to leave the 4th root of x as it is. It can't be simplified any farther than that.